Hello, everyone. My name is Anita Keshmirian, and my research is on causal reasoning in humans and large language models. So imagine that we have a drug, and then this drug would lead to an effect B. So this can happen through different causal structure. It could be a direct cause, but it could also be the case of a common cause structure that on top of effect B, you also have effect A. And then you could also have a chain structure that something, for example, would lead to that the patient would take the drug, and then that would lead to the outcome B. But if you're a rational agent, and if I ask you to estimate the probability of the drug, the causal power of the drug on B, the prediction of the rational model, according to the Bayesian models, are that the causal power of C on B would be basically irrelevant of A if you are basically conditioned on C. So once you know that the patient took the drug, A is irrelevant here because they're from the same Markov blanket class. So this is basically the research that I wanted to do to investigate this in large language models and also in humans. The question here is that are we rational agents? Are we human rational with respect to this effect? So that was the first part of the study. I asked the participants to estimate the likelihood of effect C on B. So again, if you're a rational agent, there shouldn't be any difference across different causal structure that you can see here. And the prediction of different theories and different models are basically different, and you can see researchers are all over the place. So the first part of the study goal was basically to investigate these prior theories that we have in causal reasoning in humans. But the second part is basically related to large language models. The question here is that are large language models closer to human data, or are they basically rational agents, or somewhere in between, like on this spectrum? Why is it important? So for cognitive science community, this is important because we know that we humans, we don't really learn language. We don't learn causal reasoning through language only, right? We also interact with the world physically, and so the question here would be that would language data be sufficient to introduce human biases in causal reasoning or not? It's also important for AI community because the question here would be that could LLM talk causality or not? Are they just causal parrots that they just repeat whatever they have in the data that they're trained with, or they can actually understand or reason causally according to the Bayesian rational models? It's also important for the applications of AI because we know that in many domains, like medical domain or causal domain, legal domain, causal reasoning is actually very important. So here the question would be that if these biases would be basically implemented, so that would have like huge implication for applications of AI. So we tested different scenarios across different causal structure in human data, and this is something that we have, like the data that you can see here shows basically they are consistent with the mechanism hypothesis. So people actually perceive the middle node in the chain as more causally potent, even more than the direct cause. And this was robust across different contexts and different stories that we use these structures. Then we queried the same questions from large language models, different models, and we calculated the Wasserstein distance between two different distributions, the distribution of the chain and the distribution of the common cause structure, right? So we also manipulated the temperature of the models to see if we could see any effect of the temperature. So this is what I'm going to show you now. On the vertical axis, you can see the Wasserstein distance. If you are a rational agent, this should be 0, right? So on the horizontal axis, you can see the temperature of the models. And this is, so now I'm going to show you the models, basically. This is the human level bias that you can see here. And this would be the data across different models that we use. And as you can see, like at higher temperature, all models, they converge to the human bias level that we discovered. So this was basically robust across different scenarios that we used. And the take-home message would be that the structure of causal event is an essential factor in causal reasoning in humans and large language models. You can see the same pattern here. I want to thank my collaborators, Tobias from Stanford, Babak from Beckman Institute, and Maurice from Darmstadt University. This is the QR code of the research. If you want to see the data, you can scan it, and yeah, come to my poster tomorrow. We can discuss more about this effect.